most people start working for real in their 20s at the latest, which begins the productive or potentially grindy or soul-crushing period of your life. People tend to work until the age of 65, which means that you'll spend at least 2,000 weeks of your life with serious adult work, hopefully in a job that makes you feel good and appreciated or that makes the world better.
To learn robotics, you must do a bachelor's in an engineering domain for 4 years. Then go ahead and also do a master's in robotics or mechatronics for at least 2 to 3 years. And after that, get an internship or a part-time role in a robotics company and develop a practical skill set. And hopefully then you'll be good enough to work professionally full-time as a robotics software engineer. Well, this is the conventional path that almost everyone else would encourage you take if you want to work professionally as a robotics software engineer. But it takes 6 to 7 years and it involves a lot of inefficiencies in the sense that you would be learning a lot of different concepts in a lot of different domains within robotics and AI, only to realize that the companies actually value technical skill set more than your theoretical understanding. Of course, theory is important, but what if there is a much more efficient way to learn robotics and transition to robotic software engineering? What if I told you that you can actually become a self-taught robotic software engineer within a span of a single year without going for a master's program and without spending a single dollar on your education? That's right, you can leverage most of the free resources on the internet to gain enough skills to work professionally as a robotic software engineer. And in this video, I'll be giving you a month-wise yearly plan to become a robotic software engineer by the end of 2024. There are a total of 52 weeks within a single year, and if you choose to spend every single one of these weeks really wisely and direct your attention towards your goals and on acquiring and cultivating the right skill set, there's no reason why you cannot learn the skills to become a robotic software developer by the end of 2024. So I'll be giving you a month-wise plan on how you can use every single minute of 2024 wisely and cultivate that skill set in the most efficient way possible. So first of all, how should you start? Now, within the month of January, you should be dedicating some time to set goals really concisely, setting smart goals, setting the goals that can actually be achievable by within a span of a single year. So before you even start setting your goals, first of all, you should be absolutely clear on what your core motivations are for pursuing robotics. Why do you even want to pursue robotics, a professional career in robotic software engineering? And I've talked about this idea many times before because this is such an important concept and nobody talks about this enough. Uh, the idea that you should be pursuing a field for the right reasons, because it would take you at least 1 year if you follow all of the steps that I've given you in this video seriously and commit to dedicating a lot of time and effort towards building the skills, or even more if you have less time available because of your full-time job or because you already are enrolled in a bachelor's study program. So it would be a significant time investment, and even after you have become a robotic software engineer, you would still need to learn a lot of skills because you still need to be constantly enhancing your skills, because this is a very competitive field in the sense that there's a lot of breakthroughs that are happening at a very fast pace and you need to be constantly learning new things. So make sure that you choose to learn robotics for the right reasons. And one particular practical activity that you can do to identify your core motivation is as follows. You can take a sheet of paper and write on the top of the sheet of paper, why do I want to pursue robotics, and then set a timer for 30 minutes to 1 hour, maybe even more, and really journal freely on answering this question, on trying to answer this question. What are your actual motivations on wanting to pursue robotics? Is it because you're genuinely motivated by some aspect of robotics? Did you learn a little bit of control theory and you're fascinated by the control theory, control engineering, and you are really curious on how this applies to robotics? You see these Boston Dynamics robots performing backflips and parkour and all these complicated movements. You see autonomous driving technology, and you want to apply your knowledge and skills and controls towards robotics. Is it your reason, or is it because you see that a lot of your friends and a lot of the people you know are actually pursuing machine learning, and that is why you want to go in the machine learning side of robotics, because this is something that you think everyone should learn, because hey, artificial intelligence is the future, hey, robotics is the future, and if you're not learning these skills, you are getting left behind. And yeah, to a certain extent that is true, but it doesn't have to be the core reason for you to pursue robotics, because there's still a lot of different other fields that one can pursue. And your core reason to pursue robotics should be because you're genuinely motivated by a particular aspect of a field, and you have spent a certain amount of time really being engaged in a certain field to have that foundational understanding, so that you can say that hey, if I learn more, I can contribute more to this field, and you see that there's an I can create a meaningful impact within this field. So regardless of what your core reasons are, spend some time really journaling freely, contemplating on it, and take this activity very, very seriously. You can spend a couple of days or multiple days if you need to, but make sure that you come up with at least 5 to 10 clear reasons of why you actually want to pursue robotics. And once you have done this activity, go ahead and watch my video titled Why Study Robotics, the top reasons to pursue robotics, and this is on my channel Learn Robotics and AI. And also watch the video titled The Top Wrong Reasons to Pursue Robotics. Don't pursue robotics for these reasons. And once you watch these videos, you can then compare the reasons that you noted down for yourself, the reasons that you came up uh, after completing this activity, and you can compare your reasons with the reasons that I've provided you in these videos, and you can identify for yourself whether you're positively motivated by robotics, whether you are influenced by society or some external uh, circumstances, and you're not genuinely motivated to pursue robotics. So these are the things that you should be doing. And once you have done that, then you should immediately go ahead and start setting a specific and meaningful goal for 2024. And this should take you not more than 1 week. And of course, if you say that hey, 1 week is more than enough for me to identify my core reasons, and I'm already motivated to pursue robotics, I'm doing it for the wrong reasons, maybe 1 week is more than enough for you, and then you can spend 2 weeks for goal setting. So you can adjust the plan according to the time that is available for you, and maybe for some of you, you might require less time for certain activities and more time for other activities, and so on. Maybe you have other commitments that come up along the way, which means that there's enough buffer time that is available in this plan. So goal setting. So as you talk about setting goals for the year 2024, of course, in terms of learning robotics, you can say that I want to become a ROS expert. You can also say I want to master machine learning by the end of 2024, or getting a job in robotics could be something, could be a way of defining your goal for 2024. Or you can say, hey, I just want to simply learn robotic navigation within this year. Or if you're more ambitious, you can say, I want to become an expert in robot manipulation. Or you could simply say, hey, initially I just want to get an internship in a robotics company. And these are some ways of defining goals. And if you resonated with any of these goals, then I have a bad news for you. All of these goals are actually not even goals. They are absolutely wrong ways of setting goals, for the very fact that these are not even goals. I wouldn't categorize them as goals. These are actually wishes, because these are not in your direct control. These are not goals that you can directly control. It's not in your control to get a job in robotics. What is in your control is applying for a certain number of jobs. Getting a job has a lot of other uncertain parameters that you cannot really control. Likewise, becoming a robotics expert, what does it mean? What does it even mean? What does mastering machine learning mean? These are also extremely vague, and these are not smart goals. These are not specific enough. These are not measurable. These may or may not be achievable within a span of a single year. These may or may not be realistic, and these are definitely not time bound. So all of these things make these goals actually bad. These are bad ways of defining goals. Now that you know that these are not realistic ways of setting goals, how should you actually be setting goals then? So instead of saying that I want to become a ROS expert, you can actually define it in a way that is actually controllable for you. Becoming a ROS expert is not in your direct control. It's also super vague, as I said. It's how do you even get to know whether you became when you became a ROS when you become a ROS expert? So what is in your direct control is saying something like, I want to build 3 mini projects in ROS, or I want to complete a machine learning course, and I want to build one project by the year 2024. I want to complete 3 mini projects in navigation, perception, and manipulation. This is definitely doable within a single year. You can say, I want to build one project based on my interest. You can also define a time related goal. I want to spend a minimum of certain number of hours on programming. If you are not sure on uh, what kind of projects you should be building, you just want to improve your programming skills, and one specific way of measuring that is the number of hours that you spend programming. Another thing is, you can say, I'm interested in navigation and I want to finish a major project in robotic navigation within this year. So these are all reasonable ways of setting goals. Now the first two goals that you see on the top, defining building 3 mini projects in ROS and completing a machine learning course and building one project, these are foundational uh, goals. This is under the category of setting the foundation. And another important aspect of learning robotics that you should be focusing on in the beginning is finding your niche. So you have to spend some time setting the foundation, which means you have to define certain goals that allow you to set a foundation in robotics, and then you should define some goals that allow you to find your niche. So the next two goals: complete 3 mini projects in navigation, perception, and manipulation, build one project based on your curiosity. These are some examples of goals which, if you complete, would easily help you identify your niche. So if you finish 3 projects in 3 different domains of robotics, of course you can then understand which domain of robotics you're really interested in. So these are goals that help you identify your niche. And you also want to set a goal of mastering your niche. So once you've chosen a niche, you want to define goals on really cultivating a strong skill set within your niche. So building a major project in navigation, if you've chosen navigation as a domain or your niche, is a good goal. Spending a minimum of 365 hours, 1 hour a day on Python programming using ROS, this is also a meaningful way of setting a goal that would allow you to master your niche. Okay, so these are the 3 phases of goals. Now, as I mentioned, I want to work as a robotics software engineer. This is a wrong goal. This is not even a goal, this is a wish. A better goal is I want to build 5 ROS based projects within 1 year, and I want to apply it to 30 companies by the end of 2024. So this is a goal that, if you're not sure, hey, how do I define goals, just choose this goal and dedicate the year 2024 towards it. You can say that in this year I want to build 5 ROS based projects and I want to apply to 30 companies. That's it. Now we'll see how to achieve this goal within a single year. So first of all, this goal is specific. I've clearly mentioned that I want to do 5 ROS based projects and I want to apply to 30 companies. So very specific and very measurable, and then it's also achievable, because this is not unrealistic. Like, doing 5 ROS based projects within a single year is absolutely doable. And you can, of course, reduce the number or increase the number depending on how much time you have available. This is just an example. And this is relevant and also time bound within a span of a single year, within by the end of 2024. It has a well defined objective. It should be aligned with your long term goals. So if you are interested in pursuing navigation as a career, then you can set a goal as I want to build 5 ROS based navigation projects. Or if your goal is to just uh, gain basic skills in robotics and you are an absolute beginner, you do not know your domains, then you can say, hey, I want to just build 5 ROS based projects, and these can be and should be in different domains of robotics. So and I'll talk about how to further break down these goals in the coming slides. These goals are under your direct control and these are SMART goals. Now, once you have defined these goals, you want to create a plan. You want to create a system, and this is how you would be spending the entire month of January. Just really identifying your core motivation, setting the goals, and then creating a plan. And this is really, really important, because maybe you take a few months more than 2024. Maybe you require a little bit more time because you have less time available, but you can make a plan according to the time that you have available. And I'll be giving you a very specific plan in this video, so don't worry about that. So first of all, make a commitment. If you have a clear set of whys, if you have identified your core motivation, if you have defined a goal, then make a commitment that no matter what, now I will give my best and I'll make a transition to robotics software engineering within this year. So this is the specific goal that you might have set. Or more generically, you would say, hey, I want to build 5 ROS based projects and apply to 30 companies within this single year. Now, looking at the learning framework that we had a brief look at, and dividing these goals into specific goals that are further in our direct control, we want to say that, hey, I want to build 5 projects, but at the same time I do not have any foundation in robotics. So first of all, I need to take up some crash courses to build a strong foundation in robotics, and this is something that you would need to do in order to start building these projects in the first place. So this is a prerequisite, you can say. So yeah, you say, I want to complete a certain number of crash courses to learn different robotics tools in the industry. This is one specific aspect of the goal that I want to achieve. And then you can say that, hey, my overall goal is to do 5 projects. I can say I want to do 4 mini projects in 4 domains of robotics: perception, planning, learning, and control. And based on these projects, I would define my niche and then build one major project. So this just covers the overall goal of completing 5 projects within the year. So this is reasonable. The first goal is again in the category of setting the foundation. The second is going to help you find your niche, and the third is then a major project that would help you master your niche. So these are how you should be setting your goals. Now, the first foundational goal is, it seems a bit vague: complete crash courses to learn robotics tools in the industry. And this is the first set of uh, subtasks that you would need to do. And I'll be giving you a specific set of tools and skills that you would require, and on which month what specific tool should be learned and things of that nature. So stay tuned to that. Now this is important to define how much time you want to spend learning this. Now since this is the foundation, I would say that you spend the next 6 months really building this foundation. Now it would require uh, this amount of time to build that foundation. You could do it a bit quicker if you already know some of the tools, but I would say as an absolute beginner, dedicate 6 months to it. So the next 6 months would be dedicated to learning the skills to build the foundation. Okay, then after that, how much time should you dedicate on building 4 mini projects in perception, planning, learning, and control, and defining your niche? I would say 2 months are enough. Now, you might be a bit skeptical at this point. You would say that, hey, it doesn't make any sense. I should spend 6 months building my foundation and then just 2 months doing 4 projects. Things would be clear as I explain the rest of the plan. But the overall idea is that the foundational skills are very, very important. And then these projects are basically mini projects that help you identify your niche. And these projects can be done within 2 weeks each. So 1 to 2 weeks each. And the goal is to uh, do small projects to then understand, hey, what are the different domains of robotics that I really enjoy working in. So that is the whole idea. So 2 months are more than enough. And if you obviously require less time to cultivate the foundational skills, you can spend more time doing the mini project. So again, feel free to adapt this plan according to the time that you have available. Now then you would say, hey, I want to build a major project, and you can spend 3 months fully to building this project. Now if you are willing to spend more than 1 year uh, mastering your niche, you can do multiple projects. But since I promised you that I'll give you a plan to become a robotic software engineer within a single year, you should do dedicate 3 months doing a really good project, and that is absolutely possible. Now, once you have done that, you should prepare your CV, cover letter, and all the documents that are required to apply to robotics companies. Create a strong portfolio of the projects that you have already built now, which are 5 projects, and apply to 30 companies. Now, you can see that all of these things have been broken down into sub goals, and you should spend just 1 month on this. So the last month, that is December, would be spent towards this. Okay, and lastly, you should be scheduling things on your calendar. So let's take the hypothetical case that you are working a full time. You have a full time 9 to 5 job, and you do not have a lot of time available. So you can schedule some hours on Monday, Wednesday, and Thursday, uh, learning some of the foundational concepts in robotics or building some projects, and spend some time on Sundays and Saturdays, depending on how much time you have available. If you can dedicate more time, obviously, you'd be able to gain skills faster and maybe build more projects. So, what I want to emphasize here is that you should be spending time uh, putting things on your calendar so that you really stick to the learning process. Now, another important thing that I would like to mention is that since it is an ambitious goal to really learn all of these skills within a single year, you would have to make a certain sacrifice. And these are not really sacrifices, actually. You need to learn to be more efficient, and that means eliminating useless time that you spend scrolling through Instagram, Facebook, TikTok, YouTube, whichever social media apps that you spend your time on. If you spend a lot of time playing video games or partying or whatever, you would have to cut down a little bit of that time if your goal is to really make that transition within a single year. And if there's nothing, absolutely nothing wrong with spending time on social media and uh, enjoying or playing sports or doing these kinds of things. But since you have this goal, you have to be a bit realistic that it would require a certain level of dedication. So reduce it significantly. You don't have to cut all of your hobbies entirely, but you would have to reduce it. And especially this time on social media, which is just idle browsing which is not giving you any value anyway. So consider that. And also use a time tracking tool. I personally use Toggle Tracker. And if you have set a goal such that as follows, such as hey, I want to spend 365 hours within the year programming for ROS projects. So how would you really know that you achieve it? You would have to measure it, and this is an app or a tool that you can use. Toggle Tracker would really help you track where you're spending your time. You don't have to track all of your activities. You can just track the time that you spend programming, learning robotics, and cultivating the skills. So this is very important. And you can watch my video titled The Complete Robotics Productivity Guide. It's also freely available on the YouTube channel. It's a long video. It's a 2-hour video, so I'm not talking about all of the productivity tools again. Uh, if you are looking for an efficient system to learn robotics, there I've talked all about productivity and all of the tools that I personally use and that you might find interesting. Okay, so create a plan. And once you have set your goals, defined your core motivation, created a plan, the next month of February should be entirely dedicated towards learning mathematics. Now, a lot of you would have a certain level of engineering background. Maybe you are already enrolled in an engineering program, so you would have multiple mathematics courses in your university, so maybe you do not need to spend that much time. But if you are a bit rusty on your mathematics concepts, you can say that, hey, yeah, I want to brush up on some of these mathematics concepts. And the reason why I say that just 1 month is enough, because you just need to know the right uh, concepts, and you can actually practice some of the basic fundamental concepts. Now there is a video titled Top Skills for Robotics in 2023 or something like that on my channel, Learn Robotics and AI. So there I have talked about the mathematics concepts. What are the mathematics concepts that you should be focusing on for robotics? So go ahead and check that out. Maybe I'll also make a separate video talking about what are the mathematics concepts that you should be learning and what are some good maths resources for robotics that you can follow. But for the sake of this video, I'll give you a practical resource which I've also talked about in my video titled Become a Self-Taught Robotics Software Engineer Step-by-Step Guide. So this is a resource called Rob 501 Mathematics for Robotics. This is a really nice YouTube course by the channel Robotics, or University of Michigan uh, Robotics Lab, and this is a really good resource to follow. So not to confuse you a lot, I'm just giving you one good resource that you can follow, and you have a month time to really go through the modules. And if some of the mathematics concepts are already familiar to you, or you have already have a strong foundation, then you can of course skip those or do not spend that much time on that. And 1 month is enough to build a basic mathematics foundation, and you would build up on that mathematics foundation by doing projects and using those in actual uh, robotics projects and simulation. Okay, so February should be spent learning mathematics, and once you have a basic mathematics foundation, you can go ahead and set up your system and build a software engineering foundation. So learn the basic tools for software engineering. And the first step would be to dedicate almost 2 weeks to setting up your system. So first of all, you have to switch to Ubuntu. This is also something that I've talked about previously. If you're currently using Windows, make sure that you consider transitioning to Ubuntu, because this is something that is being used by the companies. If you look at a typical job profile for robotic software engineering, you would say that a lot of these companies have Linux skills as required in their job description. So this is something that is important to do. So there's a Linux crash course to understand the basic command lines of Linux, and this shouldn't take you that much time. So within 2 weeks you should be able to install Ubuntu, and you should be able to learn and get familiar with the Linux command. And remember, the goal is just to gain a certain level of exposure to it, and you would be using these more as you start building projects. So just to get familiar with it, just to learn the basics of these things, just to practice some of the command line tools. So Linux crash course, this would be a couple of hours long on the YouTube channel Free Code Camp, and a lot of these resources that I'll be sharing in this video are um freely available on YouTube from some of these really nice YouTube playlists. After that, install Visual Studio Code. This is an IDE that you can use to start programming. This is a programming environment and it's easy to install. You can just go ahead and follow the official tutorial on uh, Visual Studio Code's official website. So you also need to create a conda environment. So this is another thing that is a part of setting up your system. You need to create a conda environment, and you can easily just Google search conda and you'd be able to find how to install conda, what conda actually is. And I'm not talking about these things in a lot of detail here. I'm just giving you the keywords that you can follow, that you can easily Google online. So conda basically allows you to create multiple environments for different packages. So if you have different projects that have different dependencies, so let's say you have a machine learning project and that requires TensorFlow, that requires NumPy, and that requires a certain uh, dependencies or certain packages, and then there's another project that requires PyTorch or scikit-learn or some other set of packages. So then you need two different environments, and then conda allows you to easily create that. So again, not going in too much detail, go ahead and look up conda, install conda, look it up on the official website of conda. All right, so this is all you need to set up your system. And after that, dedicate 2 weeks to learning Git. Again, this thing is modifiable. You can spend 1 more week to setting up system if you are having trouble installing Ubuntu or learning the Linux commands, and spend less time learning Git if you do not require that much time. But I would say spend 1 to 2 weeks learning Git, because Git is a foundational tool in software engineering. So learn Git. Git is a version control system, and this is a prerequisite for most of the robotic software engineering positions, and not just robotic software engineering positions, general software engineering positions. So I myself have a video titled "The Complete Git Guide: Everything You Need to Know to Learn Git" on my YouTube channel. So you can go ahead and watch that, or you can watch any Git tutorial video. There's a lot of freely available good quality Git tutorial or videos or crash courses available online. All right, so the next month is then dedicated to learning programming. So I would say spend 2 weeks or more learning Python. This is very important because in robotic software engineering, both Python and C++ are used. So spend some time learning Python. You can follow this resource on this YouTube channel called Bro Code. It's a full Python crash course of 12 hours. So it's a really long course. So you can spend 2 to 3 weeks really practicing Python, and don't just passively watch any of these courses or tutorials. You have to do it in a hands-on fashion. You have to practice typing these commands, you have to practice these programming concepts and use these things. So play around with it, have fun with using these Python concepts, and if possible try to build a mini project. You don't have to do that, but if you can, that would be a lot more fun and engaging, or at least try to use these concepts for your own uh, fun little activities. So if you say that, hey, this is a particular command, then this is how it is used, let's say numpy array declaration or whatever, and then you can say, hey, I want to define my own arrays to use in a calculator program or something. So be creative with it, have fun with it. The goal is to also the goal is of course to learn these skills, gain a foundational understanding, but also enjoy the process, because uh, these are the skills, these are the tools, these are the programming languages that you would be learning and using as part of your job. So make sure to enjoy the process, and if you require 1 or 2 weeks more than you planned, that is absolutely fine. If you're enjoying it, you can spend more time, and slowly, as you are partaking in these playful activities, you would also be able to identify what are the things that you enjoy doing. So this is very important. Have fun while you're learning. So this is a Python crash course, but as I mentioned, C++ is also widely used, especially for low level control tasks or tasks where you actually have to control the robot, or you have to work with hardware. So here's a really good quality C++ course that you can follow, modern C++ lectures and tutorials on the YouTube channel Cyril Staknis. So this is C++ course that you can take, and after you have built a programming foundation, you should dedicate the month of May to learning machine learning frameworks. First of all, learn OpenCV, and OpenCV is the open computer vision library that if you choose to go in the perception route, you would be using it a lot. And it's obviously good to know computer vision because it is also an integral part of artificial intelligence, and it is used a lot in robotics. So even if you do not choose to go the perception route, it's still good to know the basic foundation of it, so that if you are working in a team and there's a perception team and then there's OpenCV packages, or there are some scripts that use OpenCV, you know what is going on, you know the basic foundation of it. So this is important to learn, and there's also a lot of OpenCV courses. You can take up an OpenCV and Python crash course on Free Code Camp, or you can use and learn OpenCV in C++. I would recommend do both if you can, but if you cannot, that's absolutely fine as well. Just make sure to spend 1 to 2 weeks learning OpenCV. And after that, learn TensorFlow. The reason why I have dedicated more time to TensorFlow is because it's more general. You may or may not go in the computer vision route, but machine learning is a general skill set. So you can say that yeah, I don't know if I want to work with hardware, or maybe I don't enjoy that, I don't want to go in robotic software engineering, but then you can go ahead and find machine learning jobs. There's a lot of NLP related jobs or even computer vision jobs that have nothing to do with robotics. So machine learning and computer vision also have applications in so many different domains, not just robotics. So you can uh, spend some time learning TensorFlow, which is a basic framework used for machine learning, and cultivate that skill set, and then you can choose another domain within machine learning or computer vision if you want to. So here's a TensorFlow 2.0 tutorial by Free Code Camp. So this is how you have cultivated your machine learning skills. Now, after machine learning skills, you would be dedicating the month of June to learning ROS or ROS2. Now, I encourage you to learn ROS2 for the reasons that I've mentioned in previous videos. ROS1 Noetic would reach its end of life by 2025, and I've talked about a lot of other reasons why you should be starting to learn ROS2. So go ahead and watch my videos titled The Complete List of ROS2 Resources, or the most comprehensive list of ROS2 resources. And this actually has a lot of different resources, and I've talked about how to learn ROS2 also in this video. Uh, and then the other video is ROS projects for beginners. So go ahead and also watch this video and spend some time building these mini projects. You don't have to do a lot of projects, but make sure that you're familiar with ROS by spending 2 to 3 weeks learning ROS. And lastly, there's a ROS to Humble crash course by this YouTube channel, Robotics Backend. This is also a really good channel that you can follow to learn ROS2. This has this has more tutorials and crash courses of 1 to 2 hours long. So this is something that you can follow along, but again, make sure that you actually practice these skills along the way. And then there's also the tool called Gazebo, which is generally used with ROS. Gazebo is a simulation platform. 1 week would be more than enough to just get familiar with Gazebo, and you can follow this video uh, called Learn Gazebo or Gazebo tutorial. Just look for Gazebo tutorials on the channel Construct, and you'd be able to find a lot of different ROS and Gazebo resources. So this is a channel that I can recommend if you want to learn ROS and Gazebo, the Construct. Okay, so far we have learned mathematics, we have built a lot of foundational we have built a strong foundation in software engineering, programming, learning ROS, TensorFlow, machine learning, and so on. And now we would start to build mini projects. So first of all, you would build a mini project in the planning domain of robotics. And after that, you would spend 1 to 2 weeks building a control related mini projects in the realm of robotics. And then a mini project in perception, and then another mini project in machine learning. So notice that these projects are maximum 2 weeks long, because these are supposed to be mini projects that would give you enough understanding of robotics to then uh, help you identify your niche. So this, the goal of this is to give you enough exposure to different domains of robotics. Now you might require more than 2 weeks to building these projects, and that's absolutely fine. So if you require more time, don't be too hard on yourself. You can spend a couple of weeks more if you need to. If some other commitments came along and you were not able to follow this entire plan strictly, that's absolutely fine. You would still be able to learn a lot uh, during the year, but it's absolutely possible to do 4 mini projects within different domains of the, if the projects are just of 2 weeks long. So these are mini projects, not major projects. Now on my channel, I've created a video titled Top Machine Learning Projects for Beginners, and I've also created a video titled Top Computer Vision Projects for Beginners. And if you follow me on LinkedIn, I've also shared top machine learning projects that are specific to robotics. I've shared a list of navigation projects for beginners on LinkedIn, and then I've also shared a list of perception related projects for absolute beginners, and some control related projects for beginners. So if you're looking for ideas on what projects to pursue, you can scroll through my posts on LinkedIn and you'd be able to get some ideas. I'm actually compiling a lot of my LinkedIn posts on the website learnroboticsandai.com in the form of blog articles. So you can see that on the bottom of the screen, there are some of these machine learning project list and computer vision projects list and ROS projects lists that I have recompiled in the form of blog articles and in more detail than I shared in on LinkedIn. So you can also follow this blog, and I'll be updating this blog and adding more and more project lists on the website learnroboticsandai.com. So go ahead and check that out as well. Now, once you have built these mini projects, now you would spend just 1 week defining your niche. So you'd be reflecting on the projects that you did, the tools and the skills, the technology stack that you used, and you would uh, ask yourself a few questions. Hey, what are the kind of domains that I'm really interested in? What are the tools and the skill set? What are the tools and the technology stack that I'm really interested in? Which of these projects was the most fun for me to build? And then you would have to choose a niche. You have to select one of these 4 domains, and one particular framework that I'd also encourage you follow that will help you identify your niche is the Ikigai framework, and that consists of the following 4 components. So the first is what are the topics, the projects, or the technology stack that you use. So you have to choose which one you enjoyed working with the most. So choosing what you love doing and choosing what you're good at, you have to identify your strengths. Hey, am I more good at working with machine learning sort of projects, or am I more good at working with control related projects, or perception related, or navigation, manipulation, and so on? So you have to identify, hey, what are the things that I'm good at and what are my interests. And of course, maybe you're equally good at all of these things because they are all similar, and that is absolutely okay. You can just choose the one that you find most interesting. And then of course, uh, you can also choose the domain that you find most impactful. So you can say, hey, I want to work in the perception domain, and I see that applying perception algorithms for robotics tasks that deal with agriculture or agricultural robotics domains, that is something that I personally find very meaningful. So this is something that you can choose as your niche. You can define your niche as perception for agricultural robots. So this is something that you can then spend a lot of time building a lot of projects and mastering. And of course, there has to be enough job opportunities in the niche that you choose as well. So these are some of the concepts that you can actually find on my in my video titled The Ultimate Robotics Career Guide. So I've talked about these ideas of how to identify your niche, how to even define your career purpose statement, your mission statement for your career, and really finding a career that you not only enjoy doing, but that is also impactful and personally meaningful to you. So go ahead and watch this video, The Ultimate Robotics Career Guide, on the channel Learn Robotics and AI. And another thing that I've mentioned is that you should choose the tasks that you enjoy. But how do you identify if this is a task that I enjoy or not? It is if you experience something called flow, if you lose sense of time, and if you're totally engaged in the process, and you say that, hey, I'm balancing my current skill set and challenge, and this is a task that I'm really enjoying, and this is and I'm experiencing flow state, which means I'll be able to learn things at a faster pace because I'm also enjoying it and I'm totally present in doing these tasks. So, so follow this video, and by the end of August, you should be able to identify your niche. You'd be able to build a strong foundation in the basic concepts of robotics, and you should be able to build 4 mini projects in different domains within robotics. Now, the next 3 months would be dedicated to building your major project in the niche that you've chosen. So first of all, you'd be planning your project for a couple of weeks, then you'd be doing a literature review to help you do the project. Then you would be conceptualizing, generating ideas, brainstorming, and then you'd be spending the month of October and most of November just programming and building the project. So the idea is that you'd be learning by doing, and there's a reason why I have not mentioned or dedicated time to learning theory specifically. I mean, there is time to do literature review, so you can look up some of the concepts that would be needed for the project. So for example, if it is a robotics manipulation related projects, you can look up what forward and inverse kinematics are and brush up some of the basic concepts, learn some of the basic concepts on YouTube, or take up a course, read a book. Just gain enough to get started with generating ideas, conceptualizing ideas, building a project pipeline, and spend a majority of your time programming. So this is the main thing. You'd be learning by doing. This is the entire idea of this whole yearly plan, and this is why it's so efficient, because you can learn things as you're doing. And then after that, organize the code repository in the last week of November. So identify the problem. First of all, in the planning phase, you have to define your project. You have to say, hey, what are the tools that are needed? What are the basic concepts that are needed? And this is something that you would be able to identify as you do your background research or literature review. Then you go ahead and brainstorm ideas, brainstorm potential solutions, and then you select a potential pipeline for a project. So if it's a machine learning project, the pipeline would look something like generate data set first and extract features maybe, then train the model, evaluate the model. Roughly for a simple machine learning project, this is what the pipeline might look like. If it's another project, the pipeline would look totally different, but the idea is you should brainstorm ideas and create this pipeline all by yourself. After that, start programming and fill in gaps in theoretical knowledge. Now, you should have done a little basic literature review so you know what concepts to look in, but you do not have to absolutely go deep into all of the concepts in the literature review. Just as you have a project pipeline, you would automatically be able to identify, hey, I do not know kinematics, or I do not know epipolar geometry in computer vision or some other machine learning concepts, and you can fill in those gaps in theoretical knowledge. Then go ahead and check out websites such as Stack Overflow or Robotics Stack Exchange. As you start programming, you would obviously get stuck a lot. You would face a lot of problems. There would be a lot of bottlenecks, and then you can simply start learning more about the frameworks and the problems that you are facing while debugging your code. And this is the best way to learn robotics, learning by doing. Okay, so by the end of November, you would have finished 5 projects. 5 projects, one major project, 4 mini projects. You would have built a strong foundation in mathematics, Git. You would have learned the basic commands of Linux and all of the basic software utilities. So in December, spend some time preparing a portfolio of projects first. This is very important because you do need to learn to present your projects. You might have a really great set of projects, but if you do not demonstrate it, or if you do not showcase that you have learned and build the right skill set by while doing the projects, then the companies wouldn't really be impressed. So you could essentially write a small description of the projects, add a few images or screenshots from your projects, and then define the skills that you did. So this is one basic portfolio that I have used in the past, but you can essentially make a GitHub page if you are really motivated. That would give a really good impression. Make a personal website, showcase your projects there, uh, or you can just simply create this PPT as I have created. If you do not have enough time, if you want to uh, apply quickly, but I would say spend some time taking this seriously and building a really good portfolio of projects. So this is documenting your projects, and after that, prepare your CV and cover letter. These are also very, very important. This is one example of my older CV, and this is something that you can follow. If you follow me on LinkedIn, I have shared my CV fully. And then also prepare a master CV where you have all of your different projects. And then once you're applying for different positions, you would have to customize your CV to different jobs. So if you're applying for perception roles, maybe so for instance, if you're applying for machine learning roles that have nothing to do with robotics, maybe they do not care if you have raw skills or not. So you can eliminate the mini projects that you did that involved ROS, and you could apply for machine learning projects that are not in the robotics domain. So you would have to customize and tailor your CV to the jobs that you're applying. So prepare your CV and cover letter, and finally apply for jobs. Prepare an Excel sheet and make a list of the companies that you're really interested in and the companies that are practical for you to work at based on your location constraints. So maybe you say that, hey, I am in the United States, and I want to just uh, look for jobs that are in my country and so on. Uh, or if you have certain other constraints, you can take all of your personal constraints into account and make a list of the jobs that you can realistically apply to. Or you can say, hey, I'm a beginner, I would prefer to apply for certain entry level positions that I'm confident applying to, that is absolutely okay, and you can just simply make a list and then keep on applying to these positions. So here are some lists of companies that you can follow. So there's if you follow me on LinkedIn, so I shared a ROSCON 2023 post where they have compiled a list of companies that you can look at, but these are mostly US related companies. You can have a look at that if you are based in the United States, and then if you're based in Germany, here are some German startups. I've actually created a video titled Top 10 Most Cutting Edge German Startups That Develop AI for Robotics. So these are definitely really good startups to uh, work at. So make sure that you consider applying to these companies as well. So this is the video that I was talking about. And then apply for jobs. There's a job description. This is a typical job description for a robotic software engineering position, and you see that they require Python and C++. They require image processing and computer vision skills. They require ROS based skills. They require experience with machine learning systems. And you see that we have built all of these skills within a single year. Of course, you do not have a master's program, but my argument is that you do not need to, because you can cultivate those skills while doing these practical projects. So let's have a look at what you did within this year. So you defined your core motivation, you set your goals within January, and you created a plan. Then you learned and built a strong mathematics foundation, and after that you set up your system. You learned Linux, you learned Git, you set up a Conda environment, and then you learned Python and you learned C++. You took up crash courses in both of these programming languages. You learned OpenCV, you learned TensorFlow, and you learned ROS and Gazebo. And after that, you also built not just one or two, but four mini projects in four different subdomains within robotics. You defined your niche, and then you created a major project within 3 months, and then you applied for jobs after building a portfolio of projects and preparing a CV and a cover letter. So you see, all of these things might seem a lot, but it's absolutely doable within a single year. Of course, I'm not denying the fact that this would be challenging. It is ambitious to aim to want to become a robotic software engineer within a single year, but why not aim high? And then even if you require, let's say, 2 or 3 months more, you still would be working professionally as a robotic software engineer. So I think it's worth the effort to set a really ambitious goal and then aim to really achieve that.